Hey guys, this is Nick from Aguazio, here to talk to you about Featurestores, Snowflake, and benefiting your team throughout the entire ML lifecycle. So today I'm going to talk about what is a feature store and why use it with Snowflake, how a feature store fits into the overall ML workflow, and how a feature store can improve specific team workflows, and of course, a demo. So first of all, what is a feature store? In a very non-technical capacity, I like to think of a feature store as a gift from one data scientist to another. It lets one person do a bunch of work, ingest, wrangle, transform your data, and put it into a central location that other people can use and reuse and use as a basis for other projects. In a more technical capacity, different feature stores have different architectures and capabilities, but there are some similarities. So in general, a feature store should be able to ingest data, both in real time as well as batch. It should be able to store the data, and it should be able to store the data in order to serve it in two different formats. It should be able to serve the data both offline and online. Offline is give me my whole data set to train my model, and online is give me a particular record for a given key, often used for things like model serving. Some feature stores also have a transformation layer, and this is often used for feature engineering or stream processing, and this will be used to transform the data before it gets stored and served. Some other feature stores also have integrations with things like experiment tracking, model serving, or model monitoring. And this gets into more of the end-to-end nature of a feature store, in that it can actually be more than just a place to ingest and retrieve features. So consider your typical data science pipeline, right? Ingest the data, train a model, deploy the model, monitor the model, pretty standard stuff. But the feature store can actually fit into each of these pipeline components. So in data ingest and prep, a feature store can be used to ingest your data in batch and in real time, and also perform your feature engineering. For model training, you can use the feature store to retrieve the batch features. These have already been ingested and transformed, so you just need to grab the data. You can also integrate with experiment tracking frameworks. For when you log your model, you can also log what features you're using. For model deployment, you can actually reuse your feature engineering code from the ingestion step. And this, in addition to cutting down on the amount of code you need to write, it'll help mitigate train serve skew, which is a huge cause of bugs in production. You can also do things like real-time lookups and imputation of missing values or things you need to calculate before your data ever hits your model. And finally, for model monitoring, you can use the feature store as a source of truth for doing things like monitoring data drift. So you can use the distribution of your training data in the feature store, compare that to the distribution of your incoming production data, calculate if and when there is data drift, and use that as a basis for automating retraining. So as you can see, the feature store really is more than just a place to ingest and store features. So I'd like to get into more of the Aguazio specific feature store and how we're doing things. So I'm going to start with feature store ingestion. So in Aguazio, what you'll do is you'll create something that we call a feature set. And a feature set is one-to-one with a data source, whether it's a file or a Kafka stream or a Snowflake table. And much like any other tool or pipeline that you build, your final feature set is probably going to be comprised of multiple different data sources, right? Multiple files or multiple streams or multiple tables that you're joining together. And it's no different here. So what we'll be doing is ingesting multiple feature sets and joining them together later. So a feature set will have a name. It will have an entity. This is the primary key used to join multiple feature sets. It will have a description and some other metadata fields. But the ingestion interface is very simple. So you have something like featurestore.ingest. You give it the feature set that we just defined, and you give it a source. The source is going to be different depending on what exactly you're ingesting. In this case, I'm ingesting a Parquet file, so I'm going to use the Parquet source. So you can do the same exact thing for other sources. For example, using the CSV source to ingest a CSV file. This one happens to be living in Amazon S3. You can also use the Snowflake source to ingest a table from Snowflake, right? You specify your database, your schema, your warehouse, your query, all that good stuff. But from this perspective, it's a common Python-based interface to ingest from various different data sources. And I don't need to know what's going on behind the scenes in terms of Snowflake or AWS or Parquet or however I'm ingesting the data. So from here, what we're going to do is we're going to join these three together into what we call a feature vector. Now, the feature vector is a combination of these three different data sources, like a couple columns from here, a couple columns from there, a couple columns from there, join them all together. Again, we're talking about multiple different data sources here. to comprise our final data set. So the feature vector, it'll have a name. This is how we'll refer to it from now on, as well as a list of features. This is just in the form of feature set.feature. So I'll take these 4 features from this feature set. I'll take all the features, the star syntax, from this feature set, and this particular feature from this feature set. I'm actually having it in this special place here because it's the prediction target. So now when I want to get the data to train my model, right, we have multiple different data sources. Each have been ingested and transformed in their own way and now need to be joined together to give us our final data set to train the model. I can do that in one line of code, which is pretty cool. We do get offline features, pass in the name of the feature vector, grab it as a data frame. And this is what I can use to directly train my model. And if I want to receive individual records for a given patient ID or a given key, I can use the online feature service, again, just passing in the name. So let's go ahead and hop in and see a demo and see this in action. Now, unfortunately, we don't have a whole lot of time today, so I can't show everything. I'm going to gloss over the ingestion portion, but it's basically what we just saw in the slides. So I went ahead and I ingested 3 different feature sets. One is a Parquet file using the Parquet source. One is a CSV file using the CSV source. And I'm actually using the transformation engine here, doing some pretty cool stuff. Don't have time to talk about it right now. And then finally, we are ingesting a table from Snowflake using the Snowflake source. And I'm actually distributing this ingestion across the whole cluster using the Spark operator for Kubernetes, because chances are your data in Snowflake may not fit into memory. But I'm going to start this demo from the point of view of a data scientist looking to reuse features in the feature store. So once I've ingested my 3 different feature sets, I can take a look at them here. And here I can see some metadata information. I can see a list of my features and their data types. I can see transformations if I have any, preview of the data itself, as well as statistical information about all the features. You also just have a raw list of features. So these are just all the features in the project, regardless of which feature set they belong to, as well as how they all link up, which in this case is using the patient ID. So from here, you can treat this as sort of like a grocery store or like an Amazon cart. And we'll create our feature vector. We can do this from the Python SDK or the UI. I'm going to do it through the UI right now. I'm going to create a vector. We'll call this AI vec. And we'll say, this is my data set. And here you can just add things to your cart, right? Click, click, click. You'd probably spend a little bit more time on this than I am right now, but we'll say this looks good. Again, you can do this through the Python SDK. We'll say add, features added successfully. And if I go to my feature vectors, here it is. This is my data set. I could go in here and see some metadata, a list of the requested features, and some more stuff you can do. But in order to retrieve it, what I'm going to do is take this URI. So I can copy this right here. And if I go over to my retrieval notebook, all I need to do is import the Featurestore, paste in my vector URI. And when it comes time to train my model, I want to grab all my data, join together from different data sources, all into one place as a data frame. I can just run this one line of code. And you'll see I retrieve only those features that I selected using the UI, and I get them all as a singular data frame to train my model. And for example, if I'm doing things like model serving and I need an individual record for a given patient ID, I can do the same exact thing using the online feature service using the vector URI. And I get the corresponding records for these given patient IDs. So I'd like to round this off by talking about why different members in your teams may care about the Featurestore. So different members of your teams may have different priorities and different reasons for caring about a Featurestore. So for example, the data engineer might care because it's a unified interface for data ingestion, both in batch and in real time. They also don't need to provide the features to the data scientists because, as we saw, it's more of a self-service model using that high-level Python syntax. The data scientist is able to retrieve the features from Snowflake using that Python syntax without needing in-depth Snowflake knowledge, and is able to reuse the features across all their different models and projects and teams. And finally, the MLOps engineer doesn't need to build out the infrastructure for serving online features because it comes out of the box using the Featurestore. They can also use the Featurestore as a basis for detecting drift and retraining. So I hope this was a useful video on an overview of Featurestores and how they fit into the workflow. There's a lot that we talked about and a lot that we didn't get a chance to. If you're interested in specifically the Iguazio Featurestore, check out our documentation or the YouTube channel. And thanks again for the chance to present the Featurestore to the world. Thank you.